Hey, this is Steven from LegitTechTutorials, and we are back on our product design series, which is designing the dimensional control module and the automatic spooler for the multi-extruder filament maker. So we just did the last video. We just did the spooler and pulley module here, which we'll have open. So this guy here, if you remember, the last thing we did was you check the mass of the whole thing. So what we're going to do now on this video, most of the rest of the stuff is going to be smaller or somewhat shorter than what we've done, somewhat easier designs than what we've done. What we're going to do is, on this video, we're going to do those triangle, those kind of like those triangle pin things that I was talking about that go into the spool, into the hole on the spool, in between these holes. And then maybe we'll work on the shafts that go here. But basically what the shafts are going to be is they're just going to be little circles that will, they're basically going to be cylinders that either glue or printed with the other plunger pieces. But if that's the case, the plunger is going to go narrow at the bottom and then big at the top. So that means that you have less surface area on the print bed because you have to print the cylinder up. So that might cause some print issues. Again, I apologize early for my cat freaking out and doing weird stuff. Okay, so we're going to do those plunger pieces, and we're going to try to find the best way that we get those to work on pretty much any sort of spool that we throw at it. So I've already changed to inches, and I'm going to begin my first sketch. And these are going to be identical, so we're really only designing one. And then, like I said, it's probably going to be relatively quick. So we could actually, we're going to be doing a new sort of utility on this one. We're going to be doing loft, but we're going to be doing this so that we what am I trying to say? We'll do this and see if we have some time to work on another portion, like maybe the spring perch for the FSR on the pulley. All right, so I got my calipers here. And I'm going to look at how big I want the circle to be at the very end. Of course, our 3D printers are not very good at doing points, small points. So we'll just have the flat portion. Actually, let's have this be the big portion. So the bottom will be the flange portion. So the biggest that I've seen on these two spools, so let me grab my spools again. I have another spool over here that's in the box. I also have another spool up here. I'll check really quick. But I think my octave spool, pretty much all these are pretty much the same size. Let me grab my octave spool. I also have another spool that's in the nylon bag, but I don't want to take that out of the bag because I'm not going to use it right now, so I don't want to have it take on moisture. Alright, so let's take a look at what my octave is. My octave is, again, 2 inches, so it's pretty much, each of them are off by not very much. This is 2.04, 400ths of an inch off. This is 203, 204, pretty much the same exact thing. And then this is the small one. This is like 1.5. Yeah. So 204, 1.5. So 204, let's do 2.50. So this is the big side, and then we're gonna have another side that's up here that's a smaller size. So how we're going to do that is we're going to construct, and we're going to say an offset plane, and then we're going to have it go up. Now Okay, so now this is the important part. It is to taper it correctly so you get the best engage on the side of the spools. So how am I going to test? How am I going to check that? Number one, let's see if I can get the end of my caliper in there, which I'm not going to be able to. Maybe if I split it. No, it's just slightly too big. What if I do this? Nope. So I'm not going to be able to get it in the small one. So let's try it in thick. Oh shit. Accidentally pulled the wire out of the little holder piece. And that reminds me, when I did my spool holder, I didn't put the little filament holder, the little filament holes. Okay, so let's see if I could get this guy. Nope, it's just a little. Oh, no, it's just a little too small. Anyways, I'm gonna say it is about ½ inch. So the thickness of the lip is about ½ inch. So what we're going to do is we're going to adjust how far this is, and then thus we'll adjust our loft to be the right size. And why I'm saying right size is that it has to be the correct taper to where when we put rubber on this guy, it has the best engage on the lip of these pieces here. So it has to have the best engage. So this guy, the main stuff that I use Proto Paradigm most of the time. This has just a solid cylinder in here. There's not like a lip or anything like that. So basically what I'm saying is the least steep angle that you could have is going to give you the best engage with the lip. So what I'm going to say here, and when I say least angle, of course, what that means is that you have to have the higher the height, the less steep the angle, the lower the height, the more steep the angle. So what I'm going to go off of right now is just length. So I'm going to say 2 inches, and we'll take a look, see how that works out. And also, it will depend on what we have as our final circle. So, that being said, if I make the final circle bigger, it will not have to have as much of a taper. So, maybe even 0.75. Because like I said, this has to work on every single... This has to work on every single spool, preferably. Create sketch. There we go. Circle. And then this is going to be the smaller circle. So let's do 0.75. See what we look like here. Now, if we go down here, we see that we have the area for our loft. So let's go ahead and stop that. And then we're going to loft from one side to the other side. There we go. And profile free. It's actually the first time I've lofted in that's trippy. It's like a spline. It's almost like a torsion. It's kind of like a torsion. That's what it looks like. It looks like an angle of torsion here, off center. Looks like I'm putting a torque on. I would be putting a torque on this side, because here there's no torque. You can do other weird stuff. That's cool. Anyways, let me cancel that and redo it. Off from here to here. I don't know what most of this stuff does. I don't know what these selections do. Guide type, rail, center line, rail. Okay, well, so now you can probably get a better idea of what it would look like here. So this is our cone, and what will happen is if you look here on the left side, so this will be on you know, through a hole here and through a hole here. And then that will be pressed into the spool with rubber lined around this outside, so that it could grab onto the so it could it could have friction against the side of the ABS plastic. And I'll have to pick a material that has good static coefficient of friction from the rubber, whatever rubber I pick, to the hard ABS. Of most of these spools are ABS, or some sort of ABS hard plastic. So I need to find you know, high coefficient between those two. So this is going to be shoved in from this way, and then there's going to be one that's shoved in from this way. So this is going to be duplicated. So we're going to need one more piece on here that will not be loft, and that is the hole that goes through it. Because you need, and it's also not going to be, now that I think about it, it doesn't have to be all the way through. We're probably only going to do it a short way. So this is the first time we're actually going to have a hole that's actually using the hole tool instead of just does it do the point? Yeah, I think so. It's actually the first time we're going to use the hole tool instead of just drawing a circle and having it protrude. Okay, so what I need to do, instruction. Oh, so plane 1. There we go. And then this guy is 0.6 deep. So this is just going to be a hole where we're gonna glue the shaft, or we could thread it in there. Probably glue it. So obviously the one thing that we want right now is we don't want it to go. We want it to be long enough that it would, you know, that's not really one of our worries right now. Okay, so we're gonna edit this feature. I'm going to make it 1/2 inch. Oops. This is depth. 1/2 inch, 1/2 inch. 118-degree angle. So here what we're going to do is I'm going to do a little trick, because if you notice here, this has a because we're printing it, and we're probably going to print this surface. I'll have to look at it and see if this surface could be printed, because otherwise we don't really have to worry about it too much. But if I use this surface to print on, this is going to be, the pieces that you put on top is going to be floating. And 118 is way too high for that. So I'm curious now if I do 45, because most printers could do 45. Obviously when you shove the dowel in there, it's going to bottom out, and once it starts to hit the triangle. So now I'm curious on how that will work if you put a triangle. So hopefully you guys can understand what I'm saying here, is that if I print, you know, like that, where what's down is on the build plate, then if I just had a tapered hole with 118 tip angle, which is standard bit angle, it will be floating, because when it tries to cover this hole, when it tries to cover this hole, you know, when it tries to start to print this stuff in, it's going to be you know, printing over nothing. So the best idea is to obviously be able to print it on this side with this, but this is a very small, you know, 0.75 to get all the way up to 3 inches or whatever I put this thing to be. So that should be good for this guy for right now. Of course, we're gonna have to print it and see how it goes, but yeah, it looks good. So I'm not going to be able to do the dowel in this, not the dowel, well yeah, I mean it's the dowel, the shaft, the drive shaft, whatever. One of them is going to have a drive shaft, the other one is going to be, what's it, has me thinking it probably shouldn't be a hole. Probably should be like a triangle, so that it's extra, especially on the drive side. If it's a triangle or a square, less likely that it'll slip, and to the point where you're relying on the glue less often, because you know you can't drilling squares and stuff like that in steel is hard, but 3D printing is super easy. So we need to take advantage of our 3D printing technology to give us the best strength of parts. So if this was a triangle, it will, and it's trying to spin and drive this guy, we are less worried about the shear stress on the glue on the inside of this, trying to rip the bond between the same type PLA and this sidewall. So let's actually do that. I like that idea. So let's just do a triangle then. Polygon. That was the wrong one. Polygon. Inscribed Polygon. So let's do, we say 0.5. Actually, the shaft needs to be the same size as the spool module, so let's go ahead and just take a look. .635. Okay. So let's just make this 0.630. 0.630. And this is going to, let's just do a triangle. Square's fine too. I mean, let's just do a square. It's gonna give a better option for our for when we have the drive shaft at the and we have the hole in the drive shaft for the motor. Oh, but it's gonna go through a bearing. That's fine. Okay, so the square is going to be through a bearing, so it's going to have some support on these corners here. So that makes it that, you know, the more corners we have, the more support we get. Anyways, for right now, we're going to go with that. We'll figure it out later. In later videos, we'll talk more about that type of stuff. Distance 0.50, cut, and there we go. There's our hole. So now the drive shaft is, you're just going to glue it, goes in there, it's good to go. So main thing that we're worried about is getting glue on this flat piece there and then on the sides. Alright, so maybe we'll do a little bit on the spring mount. Okay, so first thing that we're going to need to do is we're going to need to do a circle that's about that size. Now that I think about it, this is another complicated piece. I should have probably done this piece before, because what we need to do with this is we need to actually have some holes in here, like here and here, so that they slide, so that it slides up and down on a shaft, but yet it doesn't fall off. So there's going to be like some bolts here where it is allowed to slide up and down on these threads or whatever, but yet doesn't fall off and also doesn't move. So there needs to be some holes here where we could do some PLA bolts with a spacing. So like a bolt here, and then there's going to be a spacer on it. The spacer is where the guide spring is attached to. So maybe we'll do that right now. So what we're going to need is there's going to be a circle here for the force sensor. That's going to be floating. That's fine. So what we're going to do is we're going to first draw the rectangle. So what it's going to look like, let me show you guys what I'm thinking right now. So what it's going to look like is it's going to look like this or so, and we need to change to inches. I think that was 0.75, 0.75, something like that. It looked a little rectangular. Oh. Let me go back. Measure. Oops. Oops. That's not what I wanted. Centimeters. Oh yeah, I did that to check the density. Oh, so that one was way off then, because it said something centimeters over here. So I looked at it in centimeters. Alright, well that's 1 inch. Okay, so that's what I did. Alright. So this piece is going to go in there, in that little gap. And then what we're going to do is we're going to draw a center line. Here to here. And this guy is going to be a construction line. And then somewhere along this corner here, we don't want it too close because then it's weak. We don't want it too far because it's getting close to the center. The center is also going to have the perch as well. Going to have the spring perch. I'll show you what that's going to look like. That's going to look just like on our pin. 0.15. Just like on our pins for the rollers, that perch, that same spring perch. Okay, now what we're going to do is these are going to have these are going to have some circles on them. Something along those lines. 0.15. Alright, so then on the top here, I mean, we could, yeah, it's pretty much the same thing. So we could have the spring here. So there's going to need to be two pieces. So there's going to be a bolt hole. Because there's going to need to be, yeah, a bolt hole that we could attach here. So we're going to need to attach another circle here. And then this is going to be a big one. It's going to be like the same size as, let me look. It's going to be the same size, whoopsies, this guy. This guy. So we got this. This is what it's going to look like that. Radius 0.125. Diameter quarter inch. Okay. Oops. What? There we go. And then the outside, what was my offset? This 0.35. I won't do an offset, I'll just do 0.35. Circle. It's 0.3535. There we go. Alright, so this is going to be the same thing, and then instead we're going to have a bolt that goes through here that holds the pulley on the bottom here. So this is going to go up, this is going to be extruded upwards, and then the spring is going to go here, and then some slides are going to go here. This thing's going to also be extruded up a little bit, not just these little pieces here. Okay, so there's going to be another hole here, and I'll sketch the circle temporarily for the hole. Same, 0.15. There we go. So you actually sort of see what's happening there. All right. So let's do this one. This one's going to be going through a little bit of stress. Whether or not it needs to be 1/4 inch. Yeah, it needs to be at least 1/4 inch. Okay. Go back to my sketch, turn that back on. Go top. Now what I'm going to need to do is I need to extrude this, and then this would technically need to be cut. Wait. So I'm going to need to extrude. This should have been extruded the same. So it needs to be this and this. Maybe not that. Then that's not attached. That also needs to be extruded. Okay, cool. Now we got it. Okay. So now extrude again. I'm going to want to actually feature. Don't want that for right now. So this is going to be standard thickness, and then there's our bolt hole. This is standard thickness, and then this is going to be higher. Just so we don't get any racking back and forth, forward and backward this way when it rides up and down on the bolts. So let's do this one, 0.75 or so. Oh, it needs to be almost as tall as this piece here. Alright, which is 0.3 inch. So it needs to be 0.55 because it's already 0.25, and then it needs to be 0.3 inch. So this, and this 0.55, and there we go. So what happens is there will be a bolt. There will be. Ooh, I forgot that I need to. Forgot about the offsets. I'll have that, and then see if I can do like what 0.1's too big. Yeah, 0.1's hella too big. 0.05. 0.025. Okay, that's fine. 0.025. Offset 0.025. All right, so now what's supposed to happen? So those are supposed to do that. Oh. Let me make sure that's okay. This one's okay. Say okay. This one though, I don't want it to do that. I want it to do that. I want it to also not do these. Do not do those. This one, I want to do those. All right, there we go. Okay, now it looks quite a bit better. Okay, so these two guys are slides. So what's gonna happen? They're little spacers. Like you have, sometimes you can do get bearings with them. As far as if you have a bolt, and you put some spacers on them, just some cylinders, some sleeves, and have the sleeves right on the bolts. In this case, these sleeves are going to do the same thing. They're going to ride up and down on the bolt. So there's going to be a bolt that comes here from the top and then comes down through here and then has a dead bottom here. So there's like there's going to be like a point where the spring pushes it to hit the bolt head when it's not in use, so that the spring is not always in constant, force and you have to creep or anything like that. So it's going to push this piece down to the bolt heads, which will be here on the bottom. The bolt head would be down over here somewhere. So when it's in use and the pulley is here, it won't be touching the head because it will be compressed. So it has this room to travel before it hits the head here, or even go higher. So it has this room to travel or higher. So when it's not in use, the spring will push it all the way down back to the bolt head, and that will be where it's docked. And speaking of the spring will go... Yeah, what the heck? What did they do here to the update? Like, what is this black stuff? You see the black stuff there? That's weird. It's like just that focal length right there. Anyways. So this guy is the same thing as our these dimensional controls, where the spring is going to go in there, and then the reason for this hole is this is where the bolt's going to go through and attach the pulley onto the bottom, and we still need to design the pulley. Probably should have done that in this video, but that's fine. So we still need to design the pulley, and we need to design the bolts that go through here, and have a bolt head that attaches, and so that it rides up and down on those bolt heads here. And then this guy will just be a spring with a bolt that goes over here and then attaches to the pulley. Alright, so that is pretty much it for this video. We'll design quite a bit more stuff for the spooler module in the next video. Alright, I'd like to thank you guys for watching. If you like this video, please subscribe for more videos like it in this series and other series as well. I'll see you guys in the next video. Thanks for watching. Take it easy, and peace.